Morning, everyone. Thank you for joining us today for this Internet Mobility Nexus presentation. I will be your moderator. My name is Bertrand Chirier. I'm working as an ISP sysadmin for Micrologic System in New Caledonia. To talk about the topic today, we've got three experts. Jeff Huston, Chief Scientist at APNIC. Sunny Young, responsible for 3 and 4G data access network at Telstra. And Doug Young, Manager of New Connectivity Team at SK Telecom. We're getting used, should I say more, completely addicted to living a life that's connected to the internet on a 24/7 basis. The operational environment of the internet infrastructure has been shifting toward pervasive mobility. While mobile network operations have been evolving in integrating voice, data, messaging, and video services over IP within the limited resources of the spectrum IP addresses and bandwidth, other players such as mobile devices, OSs, and apps are also constantly evolving. What impact will be generated toward mobility in the current and future internet? IPv6 has been under the radar among all of players in the changing mobility world, but it's providing tangible solutions. Android is not supporting DHCPv6, while Apple iOS is not supporting 464X LAT. So where are we going now? To talk about this today, we're going to start with Sunny, and I hope you will enjoy hearing what he has to say.
Good morning. My name's Sunny Young. Come from Telstra, Australia. Work as a senior technology specialist in wireless network engineering and a technical lead for IPv6 wireless deployment. So, deployment is progressing globally at a very rapid pace, and we're now seeing a lot of consumer networks with IPv6 deployed. We're seeing that in many countries, not just in Southeast Asia, but also in Europe and the Americas. My own company, Telstra, we've been testing for some time. And we are also planning to launch IPv6 consumers very shortly. We've been testing and testing to make sure we are providing the best possible service to our customers at launch. But there are common issues that we've identified which require a lot of discussion and consideration with other carriers to ensure the growth of IPv6 usage in mobile environments. And what I'd like to do today is show you some of these issues. But the underlying question for a lot of carriers still today is, why is it important to move to IPv6? And I believe it's a redundant question, but it's a question that's still being asked. The most obvious one has been one that's been discussed in these forums for many years, which is public IPv4 address runout. What most people don't realise is that you may also be experiencing private IPv4 address runout. Now, given the size of operations here in Southeast Asia, many carriers already do regionalisation, having separate networks in different regions. But there are some cases where regionalisation means you still need to interact with something in the central database or central data centres. And what about NAT 444? That's not really the best solution, given that you have to deal with vendors and application layer gateways for your CGNAT translations. Even internally between private v4 to private v4, which is heavily discouraged. So what do? Do you deploy IPv6 single stack or IPv6 and IPv4 together and dual stack? We have a tutorial later on today which will discuss some of these issues as well, and our other speakers will also talk about these issues. One of the other ones to consider is operational and design complexity. When you change over to IPv6, realistically it's simply dual stack. What happens if you have two different domains in the same company that you're trying to consolidate? What is the best method given that you have a private IPv4 address runout problem? On top of that, you're running out of private IPv4 addresses with your handsets for your customers. Is regionalisation and NAT 444 really the best solution for your business? Or do you really need to go to IPv6? The third issue is future-proofing. There's a lot of new technologies that are coming today. One of the big ones is the Internet of Things. How do you ensure your network is ready for future technologies without IPv6 in your network? That's a big question for a lot of carriers. And most won't be thinking that far ahead because they'll be thinking about maintaining service for existing customers. But if you're in this game, what happens in 5 to 10 years from now? But each carrier has their own unique requirements for deploying IPv6. We're not saying that it's easy. We know it needs to be done. There are different methods, and there are different requirements depending on which area of the network you're trying to configure. You can have dual stack in the core and to your users, but does that solve your private IPv4 depletion problem? You can have single stack, or you can have a hybrid single stack that uses a combination of technologies that we've been presenting over these forums for a while, using a combination of NAT64, DNS64, and 464XLAT for your handset users. All the carriers that have deployed IPv6 today in the world are using one of these combinations or another, but primarily these three different combinations that we've seen so far. And it's dependent on the unique requirements for that carrier. If the carrier has regionalization and a lot of IP addresses, they could possibly do dual stack. But if you don't, or you're a startup, then possibly you have to go to single stack sooner rather than later, because your private address might not be a problem, but your public address depletion definitely is. So, some of the issues that we think are prevalent in the deployment of IPv6 for wireless carriers are these. The first one there is continued 464X-LAT support on user equipment. 464X-LAT's been introduced about 2 years ago now, and we've seen deployment only in Android and Microsoft devices on iOS and Windows. Apple has rejected it, but have come up with their own unique solutions for iOS 9. So the question really is continued 464X-LAT support on UEs important, or is it not important? If you deploy dual stack in your network already and to your users, eventually you're going to run out of private IPv4 addresses. Do you have a roadmap to transition from dual stack to single stack for your end users? Because that may seem like a very easy challenge, but actually it's not. Because there are different considerations between operating a dual stack environment compared to a single stack environment. Another point of consideration is CDNs, because ultimately your customers need to get somewhere and download something. You've got to ensure your CDNs have native IPv6 support, even locally. So make sure you check with your CDN providers. We've been doing the same with ours and slowly activating our content provider points in our network to enable IPv6, and you should do the same. The next one's a tricky one. The application layer gateways for NAT6.4. Today you're doing NAT4.4 possibly with application layer gateways, and you may not know about it because it's either not required to be configured or activated by default. But when you transition to NAT6.4, you have to remember you are doing a brand new translation and you need new application layer gateways. Does the vendor that you're using actually support the required application layer gateways that your users are using today? I can tell you right now, they don't. The next one's a relatively tricky one, because what we've seen so far in the testing is that in some unique cases, because of the need for the application gateway, layer gateway to understand what is actually coming to the translator in the PLAT, it needs to understand the 464X-LAT translation. I can tell you the PLAT doesn't understand either. We've seen these issues because through testing, we've seen that basic URLs, basic HTTP, they work just fine. When you get to unique applications, you start seeing little gaps. And that's where we hope different experts and carriers around the world can come together in these forums to discuss these issues, to make sure there's a clear and unified user experience when people try to get onto the internet, regardless of where they are, using IPv6. But international roaming for data on a handset is going to be stuck on v4 for some time. And this is because not all carriers are using the most up-to-date revisions of software in their packet core. Until such time that every carrier has activated IPv6 in some way, shape or form in their packet core, there is actually no way to turn on IPv6 for international roaming. So that is an issue between different carriers in commercial terms, but it's something that needs to be made aware for carriers, is that you need to make sure that IPv6 has to happen for international roaming sometime or another. The question is, how do you do it with the operators that you work together with? Having said that, the next technology is very, very new. That's coming out at this moment, which is voice over LTE. Voice over LTE is over data. In the current standards, it supports dual stack. My question to you is, why would you use IPv4? It should be single stack IPv6. The general argument usually is, I need to activate dual stack and provide IPv4 just in case I need to interact with a different carrier overseas that's using IPv4 addressing for voice over LTE. I put to you the argument that if you're deploying voice over LTE, you should be on v6 anyway. So you shouldn't be interacting with any carriers that are doing IPv4. So why not do IPv6 single stack or voice over LTE? That leads on to the next question, which is voice over LTE Rabble, which is basically international roaming with local breakout. It's a relatively new standard, 3GPP Release 11. Not all vendors support it, but carriers need to be made aware that they need to support this protocol if you want successful voice over LTE international roaming with v6. After you've considered all of those issues, these 4 unique technologies might put more disruption in your network. So when you're planning your deployment of IPv6, simultaneously you should be thinking about these disruptive technologies. The first one's software-defined networking. There's a whole different forum for this topic. It's been talked about everywhere. But when we look at software-defined networking, we look at the complexities that are involved in this deployment and look at how IPv6 can be used to simplify the deployment. Because this not only affects the users, it will affect your business and your core network architecture. How do you bridge the two together to ensure you have a nice consolidated network that uses SDN? That is the biggest challenge for most carriers today. Coupled with that is network function virtualization. I've had a wonderful BOF yesterday on NFV. The question still remains though, what is the best place to actually start it in the network? And that's another challenge that you can think about and related to IPv6 deployment. How you're actually going to do IPv6 with NFV enabled to simplify your network. To even further reduce operator costs, the next one's virtual evolved packet core, and further simplifying and reducing your CapEx and OpEx. Because in a virtual evolved packet core, you are essentially using NFV. Last but not least is the Internet of Things. With an explosion of amounts of sensors and sensor networks and devices that need IPv6 addresses, how do you ensure that your core is now sufficient and built in a way to support that many devices requiring so many IPv6 addresses? So we have a lot of operators that have launched commercial IPv6 services already. The question that I pose really is, what are you going to do to deploy IPv6, considering all of these disruptive technologies and methods that are out there today? So, thank you very much.
Thank you, Sunny. So do we have any questions for Sunny from the floor? From the speakers? Okay. Actually, you answered everything.
Jeff.
So. Oh.
Jeff.
Yes.
Okay. This is Gaurav Upadhyay. from Limelight Networks. Sunny, simple question. What percentage of your total traffic is V6 now? Or is that something you can't really talk about?
Gaurav, we can't hear you properly here.
Oh, okay. This works. So what percentage of your traffic is V6?
What type of traffic?
No, what percentage?
Look, at the moment, we're not operating commercial products yet with IPv6. We're hoping to do so very soon. Our current prediction is still 50% of your traffic because you've got your Facebook, your YouTube, or your Google applications that all can support IPv6. If you look at your network traffic today, the majority of your users are using those because they consider that as the internet. So when you enable IPv6, we're predicting about 50% of our traffic. I don't think I want to go into too much detail in that because we don't have enough operational experience to give you an exact percentage.
Thank you. I think that's, I personally think that is very optimist. So we'll wait to hear from you at the next meeting.
Absolutely.
Thank you.
Any more questions? Nope. Okay, so our next speaker, Dong Kyung. Dong Kyung is a manager of new connectivity team, Network Technology Research and Development Center in the SK Telecom. His research includes applying IPv6 for LTE and broadband, IPv6 security and optical access network. His work in deploying IPv6 in the SK Telecom mobile network. So now he can share his cutting-edge knowledge with us.
Good morning, ladies and gentlemen. My name is Deung Young-go. I'm working for SK Telecom in Korea. My main research includes rest access broadband network, XGPON, NGPON2, and offline IP162 wired and wireless networks. It's my honor to with you in one of the finest conferences in the world. Actually, last Sunday, my wife gave birth. It's my first baby. However, I think it's more important to participate in this conference. So I said to my wife, say goodbye, I go to Jakarta. It's my honor to be with you. What's the first thing that pops into your mind when you hear the word Korea? Nuclear weapon in North Korea, Samsung company. Okay, I give you some question to give you a hint. Which country invented the internet for the first time in the world? Yes, it's USA. It's very, very simple question. But do you know also this question? Which country was next? It's Korea. Okay, I give you one more question. Which country invented the mobile IP version 6 internet for the first time in the world? Yes, it's also USA. T-Mobile USA commercialized the mobile IP version 6 internet for the first time in the world. Then, which country was next? It's also Korea. SK Telecom commercialized mobile IP version 6 internet last in 9. So, after this presentation, I strongly hope that IP version 6 and SK Telecom will be the first thing that would pop into your mind when you hear the word Korea. Let me have a second to give you a hint about my company who adopt IP version 6 to LTE networks. SK Telecom has more than 27 million subscribers, over 50% of the total market, which concludes the reason why it's considered dominant service provider in Korea. SK Telecom has many subsidiaries such as SK Broadband, SK Hynix, which are respectively responsible for wired broadband and semiconductor business. Today, I would like to speak about the transition schemes and issues for apply IP version 6 to LTE networks. This is the following context of my presentation. First, I speak about background. Second, I speak about IP version 6 transition schemes and issues. And further this, I speak about FAQ. From now on, I speak about background. First of all, I explain the status of Korea in the past and current. This figure shows the statistics of IP version 6 users in 2014. As you can see, IP version 6 was not almost deployed in Korea until 2014. It should affect the new emerging technologies such as IoT service. So, Korea government concerned whether new emerging technologies are lagged behind other countries. Actually, global content providers such as Google and Facebook have launched IP version 6 service, but there is no IP version 6 content provided in Korea until 2014. So, Korea government encouraged internet service provider and content provider to adopt IP version 6 to their networks. Consequently, SK Telecom and Daum adopted IP version 6 to their networks. And other company is preparing the commercial service. This table shows the summary of how to apply IP version 6 in wired and wireless networks. As I mentioned before, SK Telecom has only wireless networks. Wired networks is occupied SK Broadband, which is a subsidiary SK Telecom. Of course, our future is the IP version 6 only networks. However, the progress of IP version 6 migration is dependent on the number of the remaining IP version 4 addresses. SK Broadband, they still have the remaining IP version 4 addresses. So SK Broadband adopt dual stack to their network first. However, SK Telecom didn't have any IP version 4 addresses, so SK Telecom adopted IP version 6 only networks to their network. In this presentation, I focus on how to apply IP version 6 to LTE networks. From now on, let me explain why SK Telecom decided to adopt IP version 6 instead of NAT scheme. There are three primary reasons. The first reason, LTE device has two different IP addresses for LTE data and LTE IMS service. So as LTE subscribers grow, the capacity for that requirement will rapidly increase. And IoT market is mature, the consumption of IP address will exponentially increase. So it should burden the CapEx for that requirement. Oh, okay. And as I mentioned before, the private and public IP version 4 address have been already depleted in SK Telecom. So SK Telecom used the duplicated private and public IP version 4 network as the following figure. Under this circumstance, it is very difficult for operators to stably manage the networks. For the lesson is, as I mentioned before, Korean government strongly encouraged internet service providers to adopt IP version 6 to their networks. For reasons mentioned above, SK Telecom decided to adopt IP version 6 instead of that scheme. However, SK Telecom didn't apply IP version 6 to all access networks. The primary access networks in wired and wireless networks are respectively GPON and LTE networks. We apply IP version 6 to only GPON and LTE networks, not to the legacy networks, because legacy networks could be disappeared. Especially applying IP version 6 to LTE networks is the second company in the world, followed by T-Mobile USA. Sorry. Sorry. From now on, I speak about which transition schemes are applied to LTE networks. Oops. As you know, IP networks can be classified by the backbone and access networks. We applied dual stack to the backbone equipment, and we applied NAT64 and 464 access scheme to the access equipment. Let me explain the issues for the backbone and access network respectively. We don't need to apply only IP version 6 to the backbone equipment because the number of IP addresses allocated to the backbone equipment is very small compared to the access equipment. So we applied dual stack to the backbone equipment. Dual stack can support both IP version 4 access networks and IP version 6 access networks. Dual stack is a very simple transition scheme, so there is no technical issue. However, applying IP version 6 to access networks is more complicated than applying to the backbone equipment. There are two different scenarios to connect to the internet. The first one is when IP version 6 is enabled on content server already. The other one is when IP version 6 is not enabled on content server. Let me explain respectively. Suppose that content server have only IP version 6 stack or dual stack, and our customer have only IP version 6 stack. In this case, end-to-end IP version 6 connection is established, so there is no problem to connect to the internet. However, there is a problem when IP version 6 is not enabled on context server. Actually, Korean domestic context provider didn't support IP version 6 service. So our customer who have only IP version 6 stack cannot connect to the local context server. So SK Telecom deployed NAT64 and DNS64 equipment to support our customer. Consequently, our customer can get a chance to connect to the local context server thanks to NAT64 scheme. Let me explain the algorithm of NAT64 in detail. If our customer who have only IP version 6 stack tries to connect to only IP version 4 content server, such for example, www.naver.com. So LTE device asks DNS64 server, what is an IP address of www.naver.com? So DNS64 server responds IP version 6 address of www.naver.com. That is 64:FF9B www.naver.com. So LTE device tries to connect to the 64:FF9B www.naver.com. In our network, in SK Telecom, all IP packets who have 64:FF9B preface are routed to NAT64 equipment. If NAT64 equipment receives IP version 6 packet, it will translate IP version 6 packet to IP version 4 packet. Consequently, we can connect only IP version 6 LTE device to only IP version 4 content server thanks to NAT64 scheme. However, NAT64 has a drawback due to poor programming. Let me explain that. Some applications are hard-coded as a IP version 4 address instead of domain name. So when an application executed these applications, it doesn't ask DNS64 server. So LTE device doesn't receive IP version 4, LTE device doesn't receive IP version 6 destination address. Unfortunately, only IP version 6 LTE device cannot interpret IP version 4 destination address. So error occurred. To solve this problem, we adopted 464 extract scheme. Let me introduce 464 extract. 464 extract is specified in RFC 6877 document, but it's still in information track, not standard track. It is provided by Android OS by default. T-Mobile USA and SK Telecom adopted it, and SK Telecom think there is no technical issue in that. .464 extract has two operations, CRED and PRED. CRED stands for Customer Side Translator, and PRED stands for Provider Side Translator. The operation of CRED and PRED are respectively executed in customer cell phone and operators network. CLED translate IP version 6 packet to IP version 4 packet, and PLED translates IP version 6 packet to IP version 4 packet. Actually, the operation of PLED are almost the same, not 64 equivalent. That is, IP packet can be translated V4 to V6, V6 to V4. So we call 464 XLED. Let me explain the operation of 464 XLED scheme in detail. If Android OS find a hard-coded for IP version 4 address, for example, 1.2.3.4, and Android OS will create IP version 4 packet as the following figure. And Android OS translate IP version 4 packet to IP version 6 packet. And OS will transfer IP version 6 packet via CLED interface. As I mentioned before, in SK Telecom, all IP version 6 packet who have 64:FF9 bit are routed to PLED equivalent. PLED 64 equivalent are almost the same. PLED equivalent receiver IP version 6 packet, it will translate IP version 6 packet to IP version 4 packet. And PLED transfer IP version 4 packet to only IP version 4 content server. SK Telecom verified 1,500 applications in the Termnet on Android market. Almost the applications are properly operated, but a few applications have a trouble due to customer circumstance. But we can modify it. I speak about FAQ. Which handset OS and models are supported on IP16 service? Oops. We apply to only Android OS, but iOS. We applied Galaxy Note 4 first, and we have applied to all new devices, including tablets, since then. Do you support IMS service also? Of course, we support on IP version 6 service over LTE data and LTE voice. But unfortunately, I can't explain the algorithm of VoLTE because I'm not in charge of LTE VoLTE. Do you support international roaming service? Do you support Wi-Fi service? Not yet. We don't have a plan to launch now. Do you support tethering service? Yes, we do. LTE device allocates IP version 4 address, not IP version 6 address to laptop. Do you satisfy the quality of IP version 6 data and IMS service compared to IPv4? Yes. We cannot find the quality of difference between IP version 4 and IP version 6 service. Can I know about the increase of IP version 6 users and IP deployment since common service? I'm sorry, but I can't inform that because IP version 6 users and the CapEx for IP deployment are restricted documents. can I know about the increase of IPv6 traffic since commerce service? I'm sorry, we don't know that because listed IP equipment cannot distinguish between IPv4 traffic and IPv6 traffic. Do you inform your customer that they are serviced by IPv6? No. Our aim is that our customer cannot recognize which service is provided. Do you have a plan to launch the new business model based on IPv6 service? Yes, we do. We are considering for deploying 3GPP IoT service for nationwide. This is my end presentation. Yes, thank you very much.
Any questions for Mr. Cove from the floor? No? No questions? Well, we can carry on with our next speaker, Geoff Uston. Geoff Uston is the chief scientist at APNIC, where he undertakes research on topics associated with the internet infrastructure, IP technology, and address distribution policies. He has been a tough leader in the internet technical community since, well, the very early stage of the internet. Geoff, please.
Thank you. Good morning all, and thank you for coming. I'd like to raise this up a little and look at the place of mobility in the larger internet and even in the larger context of the communications industry. Mobiles are really important. What we're seeing now, in case you hadn't figured it out, is the death of the laptop. So all you folk with laptops, how quaint, how amusing, you're an anachronism. Almost everything that gets sold now goes in your pocket. Almost everything. So that's one from Global Stats. You'll find any of these things where they look at what's happening on the internet. Almost half of the traffic is attributable to devices that are in your pocket, one way or another. 40% of all those devices are in your pocket, and that number just rises. And the desktops and the larger machines are just getting rarer and rarer. Chip manufacturers aren't making chips for them anymore. Intel is concentrating on low power, high battery life, because that's where the money is. And it's a lot of money. If you look at ARPU, average revenue per user, mobiles are not just 40% of the internet, they're 75% of the money. So no wonder we all look at these mobile providers with astonishing attention, because they are the money in the internet, and that's a lot of money. So this is big. We talk about 3 billion users on the internet and congratulate ourselves at what a wonderful job we've done over the last 25 years. In 2014, we sold 1.5 billion smart handsets, just in 1 year. This year will be bigger, obviously. Why? The industry is processed sand. Silicon doesn't require an awful lot of expensive material, and the more you do it, the cheaper it gets. What's the cost of manufacturing one of these fantastic handsets that are supercomputers of the 1970s? About $30. I think in India they're trying to get one out onto the market for under 10. This stuff in production is cheap. And you don't have to write software anymore because Google give it away. So there's no software development costs other than basic device drivers for the particular chips you choose. And you don't need to write content because the web's full of it, right? So all of a sudden, the cost of bringing this stuff out to market just plummets. And so now we're shifting away from computers being tethered to things and moving into this new area where it's in your pocket, in your car, wherever you want to go, we can stuff a machine at you. So the industry is now looking at these new markets for the focus of its production capacity. And we're good at what we do. If we need to make 3 billion units next year, we will do that because we're very good at it. So right now, who's playing? Google make 97% of its revenue from ads. This is not surprising. Every ad you see is probably there because of Google. But interestingly, although they make no money, there's no revenue coming from it, 84% of all handsets sold in 2014 ran Android. Whatever happened to Nokia? Well, dead. Going back to making gumboots like they used to do a few years ago. Android, 84% of the market share. Almost everyone runs Android. And it's basically going the tablets, the large screens, the this, the that. You can even get desktop machines that run Android if that's what you want to do. I'm not really sure I'd do it, but nevertheless. And of course, Apple. Apple have always positioned themselves as the Gucci of the market, the affordable luxury manufacturer. Their margins are astonishingly high. They only shipped 12% of all the smartphones last year. That's not a lot. But out of that, they generated $397 billion of profit. They are the world's most valuable company. So, sorry, 182 billion profit just from the Apple iPhone itself, 397 for the entire company. So their margins are enormous because what they did do, which really wasn't where Google was at, was sell you design. And it is really slick design. So those folk dominate. The former giants, Windows, 3% market share, declining by the day. And Nokia, does anyone remember Nokia? I certainly don't. So we always thought that the mobile network and the mobile market was going to be the driver. That because the money's there, this would shape everything else. And I think that's still true. The money is still talking. We also thought that the true driver for V6 was going to be in this mobile sector. And so if the mobiles went V6, everyone else would go V6. That's what we thought. And I'm kind of wondering about that statement. I'm kind of thinking, is that true or not true today? Are these folk driving? Because life is getting fascinating. Is there one mobile technology? Does anyone remember GSM? Thank you, some of you do. One of the things, and it's an American, and this is the weird thing, because one of the few countries that totally resisted GSM was America. And the rest of us who entered the country with our GSM phones were wandering around going, Signal, Signal, where is Signal? GSM was brilliant because it was a single standard, and even the most basic telephone operators, and I used to work for one who at the time certainly had a lot to learn. GSM was like you just opened the box and followed the manual. You didn't need to understand it, you just simply needed to run it. And because it was one standard technology with one standard operating practice, and everyone who ran it, it just worked, it roamed globally, it just worked wherever you were, and quite frankly, everything worked in lockstep. And even the Americans finally cottoned into this. You know, and they threw away their PCS or whatever it was and moved into this GSM kind of world. But that was 3G. In fact, it was even before that. And the real question is, are we still in lockstep? Is this still one mobile world? Is this still one technology? And, you know, I think that's bullshit now. That realistically, this is now no longer one world. There is no longer one single spectrum. Some countries are opening up 1900, some are opening up 1700, 1800. All kinds of frequencies are being opened up. You can't just turn on your handset and get a signal necessarily. It's no longer like that anymore. Interestingly, there are a whole bunch of different business objectives. The incumbent in a particular country has one set of objectives, but challengers have a different set. And in the American context, T-Mobile's position is awfully different as a challenger to AT&T as an incumbent. So their motives are different. And the other thing is too, that now with 4G, they are so different. 4G roaming is kind of like a contradiction in terms. That the lowest common denominator for roaming is actually quite a slow 3G system. So we kind of use 3G when nothing else works, and 4G, the whole LTE thing, is actually now back to customised technology that isn't that portable at this point in time. So the industry is bifurcating, changing, splitting, moving apart. And so what this means is that different approaches are being used to V6. And so you heard a little bit of that from the talk from SK Telecom here. But if you look at it, different providers are doing different things. The first big stake in the ground was Verizon. And they said something quite radical. They said, we will roll out our network over 4G dual stack. Now, there's a couple of statements about that are impossible for other carriers to emulate. If you're running a 3G network, you're using PPP contexts or tunneling. And normally, you can't afford the hardware. You rent it. But I don't rent a box. That's just so yesterday. I rent PPP sessions by the minute. It's a bit like planes or airline companies don't own their jet engines. They lease the service of propulsion. So telephone operators in 3G lease PPP tunnels. 2 protocols, 2 tunnels, twice the cost. Why go dual stack? Because if it's twice the cost and the customer doesn't even know what you're doing, never going to happen. So that was one of these big constraints that Verizon, because it went LTE, and LTE does not use PPP contexts, it's IP all the way through, found that they could do dual stack. T-Mobile, they wanted backwards compatibility with 3G. They're the challenger. They didn't have much money. They were trying to reuse their existing infrastructure. So they made a very, very brave move. And the brave move was, we're going to run V6 as the over-the-air protocol. No V4 over the air. And we will fake V4 at either end, like SK Telecom. So the handset thinks it's got this interface that talks V4, but it's a piece of software. And it talks to another piece of software, CLATs, PLATs, ABCDE, LATs, whatever. It talks across a V6 network via tunneling. Realistically, what you're doing is simply doing one protocol in the air, because that's cheap, and faking out the rest. Another way of doing this is actually following a path that Apple is advocating, going, look, forget this 4 nonsense. If I can get all the apps on this phone, if I can control all the apps to think as if it's a V6 world, no one cares about V4. Only Apple could have that thought, because only Apple exercises such a tight control on the apps inside this device. Such a tight control. If they say all apps must do V6, I think that's what they said at the last developers conference, then that's what app developers must do. So their move is completely different. IPv6, NAT64, go for it. Or you can do various other forms of tunneling. But this exposes something else that's kind of interesting. You've heard talks from 2 carriers, radio carriers. But where's Apple's story? Where's Android's story? Where's the app story from Facebook and Netflix? Because all of these folk have a say. All of them are trying to exercise control. And so what's going on now is that we're not one technology and it's not one happy story. This diversity means that everyone has a problem. There's an imposition of cost and complexity on the industry. And that means you pay more, because you're the only person giving money into this. So nobody really wants this because it's expensive, but we have no choice. The industry is busy fragmenting and adding cost and complexity right now. So what do? Dual stack versus mono stack. If you've got the luxury of only doing a 4G network, you can probably do dual stack and simply pass V4 and V6 all the way through. But most providers want to do backward legacy with their old 3G. They haven't got a mountain of money. No one has a mountain of money. So they want to make stuff compatible, and that means they've got to fake two protocols with only one. So the typical method right now is to take a deep breath, push your supply chain, and do V6 only access. That's a brave move. The other way of doing it is just to stick with a single mono V4 network and fake V6 on top, but that's kind of difficult. So that's the first kind of question. Dual stack or mono stack? Most folk are still doing mono stack. What about the devices? There are two major device families out there. There's iOS and there's Android. iOS, Apple, right now, they don't have any preference for V6. Applications might, browsers might, but the basic libraries that are included in an iPhone actually doesn't care. So when we looked at mobile devices in measuring it in August, we saw around 5% of mobile devices that were running iOS responded in V6. And we gave them a dual stack test and said, well, if you're V6 capable, which do you prefer? And we were expecting 50%. We got 72%. It's not bad. So basically, Apple doesn't prefer 6 when given the choice in the handset. It kind of does it most of the time. However, iOS Beta 9 is coming. And this is going to be quite a significant change because they believe, and their lab tests say, 97% will go V6 straight away. So when you're given the choice, iOS is moving to V6. They are not going to support 464 XLAT, and that's been a point of contention. Why not? The reason why you're supporting 464 XLAT is you're faking out the fact that some apps don't understand 6. So you're doing this huge amount of work to just keep old apps working. Apple don't believe in old apps. Apple think that the apps had better get with it. So as of iOS 9, the app won't be in the Apple Store unless it does connectivity over 6. So Apple's preferred model is keep the handset simple and don't try and put network functionality in the handset. Push 6 all the way over to the NAT at the other edge and just do NAT 6.4 and fake it out over there inside the network. Leave the handset running pure V6 if that's what you want. Apple at this point are resisting pressure to run 464 XLAT, and they're the world's biggest company. So it's kind of like what they say will kind of go for Apple. And what this means is that folk who are running 464 XLAT, if they want to accommodate iOS phones on their network, will need to expose that underlying DNS 6.4 in the PLAT as being a different way of doing it. So even if the handset doesn't have the complementary CLAT, the 6.4 functionality still needs to be exposed. 84% of devices, though, are Android, and they're different. Again, interestingly, no preference for 6. About 86% of Android devices used 6 when we tested them, but inbuilt into the phone, doesn't care. They've no plans to change that. Unlike Apple, they will not change that. So if you're running a NAT, a V4 to 6 NAT, Android is hell. Because Android won't let you deploy 6 and sort of remove the pressure. Android isn't helping the transition. And that's kind of bad, and -1 to Google on that one. Not a good answer. It does have support for 464 XLAT because it doesn't have the same level of control over the apps. Apps are still running V4 and Google is not there to sort of put pressure on the app folk. So they've got this legacy problem in apps, so they need to fake it with 464 XLAT. Not the best of answers, but that's what they're forced to do. They don't support DHCP v6, another point of contention. Apple does. Why not? Because Google has a different vision of the thing in your pocket. They think it's a Bluetooth hub for a whole bunch of other things. And they don't think it's a stub. They don't think it's a DHCP endpoint. They think it's a router for a personal network of devices. Subtly different vision, and thereby they're saying, look, give me a prefix, do prefix delegation, don't treat me as a dumb endpoint. Different view. But there's more coming. It used to be that mobile devices stuck in the radio and they were stuck in the air. But anyone who went down into a big city in the middle of the day would find that 4G networks ran at 1.5G, if you're lucky. And if you ever went to a large match in an arena, there was no data. Because exclusive use spectrum that they rented is not infinite. And the more people you crowd into a small space, the less data. So all of a sudden, we're trying to make really fast speeds work in crowded contexts. And exclusive use spectrum doesn't work anymore. So all the handset providers and the application folk are saying, give us more spectrum. And the only place it's going to come from is Wi-Fi, which puts these operators of radio under a lot of pressure. How do you do it? Who's in control of this? And so the increasing debate in the mobile industry today is not about V6, it's actually about Wi-Fi handoff. And all of a sudden, everything is changing. And there are cracks appearing in the protocol stack as different folk try different solutions to grab a larger share of the money, because it's all about the money. So here's the old model. The application didn't care about networking, it was just a standard app. The operating system platform provided you with a library, and that was access network services that either came from radio or Wi-Fi. Whenever you moved to Wi-Fi, your switch was complete. Whenever you moved to radio, everything moved to radio. That was the model. Anyone heard of Google Fi? $20 a month. For $20 a month, unlimited data, but it scavenges. If there's Wi-Fi, it will use Wi-Fi. If there's radio, it will use radio. It has a global roaming deal with T-Mobile and Sprint, but it doesn't actually use them as a terminating carrier. The phone makes this virtual tunnel to a Google data center and uses anything it can to get there. And so it can do seamless handover from radio to Wi-Fi because the service terminates and appears to the internet from that virtual connection server hosted in a Google property. Google are trying to marginalize the radio carriers. They're trying to squeeze them out. Because Wi-Fi works so differently and actually offers you paths through congested radio systems, this looks really interesting. Google always strikes me as a disruptive force in this industry. They don't make any money from Android. It's unlikely that Google Fi will be a revenue generator, but it will be a price setter. It will influence the price that Telstra and SK Telecom can charge, because if they can't match Google Fi's performance and price, they have a problem, Google doesn't. But Google aren't the only one playing fast and loose. A number of you have Apple, I have Apple machines. You ever used Siri lately? You know, hello Apple, what's the weather today? Siri is kind of weird. Siri is the first of these ones that uses Apple's implementation of multipath TCP. And if you look hard at your phone with a protocol analyzer, and I must admit, I'm weird, I do that from time to time when no one's looking. When you analyze the phone carefully, you'll actually find that when you talk to Siri and you've got radio and Wi-Fi, both channels will be pushing data and pulling data at the same time. And whichever goes fastest takes most of the data, but both channels are open. So who controls the handover from radio to Wi-Fi? Not the carrier, not even the platform, it's Siri the app now doing that handover. And that's a real critical change in this industry. The application is now asserting control. And speaking of applications that exert control, Facebook is the new breed of complete and total paranoia. It doesn't trust even the platform it's running on. It thinks it does a better job of TCP. Maybe Facebook think that Apple look over their shoulder and spy on them. Maybe they're right, maybe they're wrong, but the Facebook app only opens the raw interfaces. Everything else is in an application library within Facebook. The application is now saying, I'm in control, it's me. Everyone else is just transport. And that always brings up this new model of paranoia, where the application and its library simply drive through whatever network's around and privatize and encrypt the conversation, hiding it even from the operating system platform. Why should Facebook tell Apple its secrets or Google its secrets? If I can encrypt all the way through, Google know nothing. And that's what Facebook would probably prefer. This is the new model of computing, where instead of leveraging other people's work, you fold it in and hide it. And you make everything completely self-contained and encrypt like crazy and view these carriers as mere providers of conduit and do your own bargaining as to which you're going to use. So I kind of have some sympathy for you. Life is going to get tougher. Your margins are going to get squeezed and other folk will be looking at for them. Voice premiums are almost over, if not already. The price pressure is astonishing. All that data service just gets cheaper and cheaper and cheaper. Google Fi will set new prices out there in the same way that Skype revolutionised voice 10 years ago. And all of a sudden it's a different set of wars where even the manufacturers, Samsung, HTC and the rest, are being squeezed like crazy. That they've got to pump their hardware out for less than $10 a unit to survive. Google and Apple are now trying to control the platform space, but Facebook, NetApp and all the rest of the content folk are trying to take it away again. So there's this massive three-way battle over who controls access to your wallet. That's fascinating. You and I as consumers want more for less. We want to be able to stream our content to our mobile phone no matter where we are, no matter when we are, and no matter how many people are around us. We want much, much higher download speeds. We want to get rid of data caps. We want lower prices. That's what we've always wanted. We're kind of greedy and we just don't care how, right? The competitive pressure is completely realigning this industry and actually pushing the power up to the app and taking it away from access. So mobiles have a real problem. They paid billions of dollars for exclusive use spectrum and it's no longer an asset. It's a liability. When Comcast decided in the US to convert a whole bunch of wired infrastructure access boxes into Wi-Fi handoff points, all of a sudden they're a mobile provider without the cost of renting spectrum. That's fascinating. It's AT&T's nightmare. So now AT&T is trying to do Wi-Fi handoff, as is everyone else. The cellular providers are being forced to follow because the market is changing right in front of our eyes. So, quite frankly, the operator's lost control. The access device is defining its own path. And once you lose control, you can't get it back. It's over. Everything is now moving into direct conflict with the mobile operator. And the mobile operator is no longer controlling this. There's increased pressure on the Wi-Fi spectrum spaces, and this is going to distort the market further. And the real battleground for the next couple of years is Wi-Fi handoff and VoLTE, voice over LTE, and keep on talking as my packets go any way you want. It's going to be fascinating, and I, for one, am going to enjoy it. Thank you.
Thank you, Jeff. Yeah. Don't forget your eyes. Any question for Jeff? Any comments? Yes, we've got a question.
Hi, Tarannum Kamal from Telenor, Pakistan. I would just like to thank you first for sharing such interesting facts. We have been discussing a lot about transition to IPv6. My question is that considering the associated challenges, the major one being the unavailability of user handsets, which are IPv6 enabled, how soon we foresee the transition is inevitable for the operators?
A number of folk here are sort of constrained by corporate confidentiality, and what they can say is always limited. I have no such constraint, So I'm able to say things and they can happily say I'm wrong or whatever if they so choose. How many folk have a 5-year-old handset? Very few. Most of the purchasing plans recycle handsets at between 2 and 3 years. There's a very rapid turnover of these things. And so the first kind of observation is the supply channels for mobiles are actually really quite up to date. The second aspect of this is how much of this is in the chip and how much is in the associated software. And so to some extent, these are standard Broadcom chips. Most Broadcom chips kind of do what you need them to do, and V6 isn't really the big issue in the chip. So the capabilities of the hardware are not the problem. When you look at the deployed capital of the base stations, the switching systems, and all that back end, it's a lot of money. And moving that around is a lot of process and a lot of cost. And it tends to be that the back end is the factor rather than the front end in mobiles. Consumers just follow fashion and keep buying what's best and what's latest. That's okay. But, you know, it's not very sexy to change your 3G SS switch. You know, no one cares. And you're trying to make it last as long as you can because it's costing you a fortune. So typically the device isn't the problem, the back end is.
Realistically, if we look at when you need to do this transition to V6, it's dependent on how critical your V4 address problems are, realistically. But that varies carrier to carrier. Even if you are not in a run-out situation at the moment, the next hardest question is how do you actually get the correct hardware into your users' hands? As just mentioned, most people change their handsets very, very regularly. So where in the device churn cycle do you actually do that transition? And how quickly can you prepare your network to support that? And that's always a constant issue for operators. So you have to decide during your churn cycle and during your network architecture design, what is the best period to support this deployment? And I would say start from the very end. Put a date down. Let's say you want to deploy next year and work backwards. And that's the best you can do.
Thank you.
Any more questions? No? I've got some. With what we've been talking about from the beginning, and I would like to know what's SK Telecom move will be next after 464 XLT and things like that. What are your plans in the future?
Of course, we are trying to find a new business model based on IP16 service. But unfortunately, we can find the use case based on IP16 service, except for LTE service until now. However, we are considering for deploying 3GPP IoT service with nationwide. So we think 3GPP IoT device should have an IP16 service, IP16 address. So I think 3GPP IoT is a killer application for IP16 service.
So what would be your recommendation for other service providers like you in the region?
I'm sure, in my opinion, I'm sure our ending future is the only IP16 network. So I recommend operator prepare for IP16 migration right now, because it takes too long time to prepare IP16. In our case, we prepared for 3 years or 3 years. But I think you can easily prepare IP16 than us, because IP16 technologies are more matured then when we are prepared, yes, you can do it.
Thank you for that. Any more questions for our speakers? Okay. No? Well, I suppose everybody's hungry now. So I would like to thank all three of you and wish you all a very good lunch. Thank you very much.